Hi, Assalamualaikum. My name is Aina Maisara, entry number DD220103. So today, my group 2, will be represent about hydrometallurgy leaching of EVs. First thing first, my group members are me myself, Aina Maisara. Entry number is DD220103. Oi Kang Lun, BD220010, and Nur Ain Syuhada, BD220011. So for today, I'm going to explain about interaction, objective, and theory for this case study. E-waste or electronic waste includes discarded electronics like computers, smartphones, TV, and household appliances. The amount of e-waste is rapidly increasing due to short lifespan and electronic and high consumer demand. In 2019, about 53.6 million metric tons of e-waste were generated globally, and this number is expected to grow. Current recycling methods like burning and using strong acids are inefficient and pollute the air and water. Many vulnerable metals are lost, and the full environmental and economic benefits are not achieved. Therefore, new and sustainable recycling methods are needed to effectively and responsibly recover metals from e-waste. Objectives of this case study are first, to explore and evaluate the hydrometallurgical processes implemented by Umicore for the recovery of precious metals from e-waste. Second objective, to assess the environmental and economic impact of Umicore's hydrometallurgical techniques and compare to traditional recycling method. And third objective, to understand how Umicore processes support the broader adoption of circular economy principles and promote responsible e-waste management worldwide. Hydrometallurgy method use aqueous solutions to recover metals from ores and waste. Process involving leaching, which is dissolving metals from solid, followed by separating and purifying the metals. And sustainability, ideal for e-waste recycling as it can selectively recover metals without high temperature smelting.
For the observation, e-waste management has traditionally used harmful and inefficient methods like smelting, acid leaching, and incineration. Hydrometallurgical process, which involves dissolving metal using solution like cyanide or acid, offer an efficient and environmentally friendly alternative. Companies like Umicore Precious Metal Refining are successfully using this process on an industrial scale. However, challenges remain regarding scalability, environmental impact assessment, and the economic viability of hydrometallurgy in e-waste recycling.
For metallurgy, I'm going to explain the process. First, pre-treatment. This initial stage involves the mechanical dismantling and shredding of e-waste to reduce the size of the components and to separate different metal types. Mechanical separation techniques such as magnetic separation, eddy current separation, and density-based separation are used to separate ferrous and non-ferrous metals, plastic, and other materials. Second, leaching. In this stage, the process of e-waste material is subjected to chemical leaching, where specific leaching agents are used to dissolve the metal components. Third, separation. Once the metals are dissolved in the leach solution, various separation techniques are applied to isolate the metals from the leachate. Techniques such as solvent extraction, ion exchange, and precipitation are commonly used. Fourth, purification. The separated metals often require further purification to achieve desired level of purity. Electrolyte refining and other purification methods are employed to remove any remaining impurified. Lastly, metal recovery. The final stage involves the recovery of purified metals from the solution. This can be achieved through processes such as electrowinning or chemical reduction. These recovered metals are then processed into form that can be used in various industrial applications.
Now I will explain about the result part. For the result part, we can divide it into 2 points. The first point is ion exchanger. In the hydrometallurgical process, metal ion can be dissolved from electronic waste and enter the solution. At the same time, the ions in the solution can also react with the metal ion in the electronic waste, causing the metal ion to be adsorbed back to the solid phase. The equation in the leaching process, M go to Mn plus E minus, and M plus E minus go back to the M. Any metal ion can be substituted by M. The second point is electron deposition. For this point, we can divide it into two parts. The first part is cathodic reaction. The cathodic reaction occurs when the electrons are absorbed from the electrolyte to the electrode surface. In leaching process, the cathodic reaction is usually a metal reduction reaction. That is, the metal ion accept electron on the electrode surface and are reduced to the metal. The second point is anodic reaction. The oxygen-electron reaction occurs when electrons are transferred from the electrode surface to the electrolyte. In leaching, the oxygen-electrode reaction usually occurs at the anode to maintain the charge balance in the electrolyte.
For the discussion, hydrometallurgical process involve leaching valuable metal from e-waste requiring optimal temperature and pH level. Solid-liquid separation is used to isolate the metal in solution, followed by purification technique like solvent extraction and ion exchange. Electron-winning deposit pure metal from solution, while waste treatment neutralize hazardous component and recover residual metal, ensuring minimal environmental impact and supporting sustainable recycling practice.
For the conclusion and recommendation part, we can divide it into 2 points. The first point, the importance of hydrometallurgical leaching cannot be ignored. The most important thing is waste treatment and recycling. This is because hydrometallurgical leaching also allows us to process metal waste and recover valuable metal such as gold, silver, and copper from it. The second point is hydrometallurgical leaching also brings some problems and challenges such as leakage and wastewater management, because in the leaching process we will use a lot of chemical things, some of which contain harmful substances. So when handling this liquid, we need to consider the pollution situation, which is also the key problem we need to solve in our future.
What is e-waste and why is it important to manage it effectively? Waste or electronic waste refer to discard electrical or electronic devices such as computers, smartphone, television, and household appliances. Managing e-waste effectively is crucial because it prevents environmental degradation, conserves valuable resources like precious and base metal, and reduces the need for mining virgin ores. Waste is both energy intensive and environmentally damaging.
For the question 2, which is what are the advantages of hydrometallurgical processes over traditional e-waste recycling method? Now I will explain the answer of question 2. For the question 2, hydrometallurgical processes offer several advantages over traditional recycling method. First point is reduce environmental impact, avoiding the release of toxic substances through incineration and minimizing hazardous wastewater production. Second point, increase efficiency, higher selectivity and efficiency in metal recovery without the need for high temperature smelting. The third point, alignment with circular economy principle, conserving natural resources and reducing overall waste.
What are the main stages involved in Umicore's hydrometallurgical process for e-waste recycling? The main stages in Umicore's hydrometallurgical process are there's 5 processes such as first is pre-treatment, second leaching, third separation, fourth purification, and fifth metal recovery. 'Cause you are